Hello, good afternoon, class 12. Today I'm very sorry I came here pretty late. I had few other assignments to accomplish, so I couldn't catch up earlier. I'm sorry for that. Today we are going to discuss some of the nomenclature of ethers once again. We are going to revise few things with the naming of ethers, and we will today also complete the preparation, properties, and uses of diethyl ether. So I will first jump to the fourth question in our textbook, and I will actually name them all for you once again. I know many students have really enjoyed this naming of ether. Some have struggled. I have seen some improvers making mistakes, and some issues there. So I want to repeat it for you. Like in the fourth question, the fifth part is CH3 to COCH3. On this question, majority students have done correct. If I have to rewrite it, it's going to be COCH3, and this CH3, there are two CH3. So one CH3 goes here. In fact, there are three. I'm sorry. One CH3 goes here, one CH3 comes over here, and one CH3 goes down. Now, many students have done it very correct, majority. Now, this is, of course, methyl, and this is tertiary butyl. So, the common name of this compound is very simple. It is methyl and terbutyl ether. Because one side is methyl, other is tertiary butyl. For the IUPAC naming, I will explain. For the IUPAC naming, I will do that with a red pen. So there's a difference between the two. For IUPAC name, we will connect this O with the CH3. So this is methoxy. And we will select our longest chain. So the longest chain is this, 1, 2, 3. So you can see that 2 carbon has two branches. One is methyl, other is methoxy. So we write first the methyl, 2-methyl, 2-methoxy. Since 3 carbon in total, so the name will be propane. 2-methyl, 2-methoxy propane will be the IUPAC name of this compound. Now, this compound can be represented in a skeletal form. Since it's propane, so it's obviously 3 carbon, and that's how we show 3 carbon. There's a 1 carbon, 2nd carbon, and 3rd carbon. Now, the methoxy is on the 2nd carbon, so we make you can make an orientation like this, O, and like this, CH3. Or we don't write CH3, just as bond. So this is 2-methoxy, and this is 2-methyl. So 2-methyl, 2-methoxy propane can be represented this way if you want to show just the skeleton. All right. Next question, which is number 6, is C2H5O, and then CH and CH3 2. Now this will be, of course, C2H5O, CH, and then there's a CH3 here, and a CH3 is here. Common name, obviously, isopropyl ethyl ether. So it's going to be ethyl isopropyl ether. So ethyl isopropyl ether, very simple. IUPAC naming, this is ethoxy. So 1, 2, 3. This is 2-ethoxy propane. Right? It's a very simple one once again. Again, 3 carbons. So this will be similar structure. Like you can, this is 3 carbon, this is O, and then this. Now you can see the difference. Here, there's just one line showing methyl. Here, after oxygen, there's a band here, meaning there are 2 carbon. 1 carbon is here, 1 carbon is here. This is ethoxy, right? And this is methoxy. 3. This obviously is propane. So this is number 6. Number 7 was the simplest, CH3O, and then CH2, CH2, and CH3. This is the simplest one. This is methoxypropane. 1-methoxypropane, or simply methoxypropane. Again, propane, so, or methyl N-propyl ether, common name. Common name will be methyl N-propyl ether. Now, if you want to make this kind of structure, again you want 3 carbon. 1, 2, 3. Now third carbon is attached to, or first carbon is attached to oxygen. So you can make O here and then this. Now, first carbon attached to O, second, third, and attached to methyl. So this is how you can represent methoxypropane with just a skeleton. Okay. Now the most important one. Everyone, like 50% of the students, they did mistake in this number 8. So it is CH3, and then there are 3, and then CO, then we have CH2, 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 and CH3. First thing first, we expand it. C, the CH3 goes here. This is the second CH3. This is the third CH3, and the O, and then CH2, 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 and CH3. Now, my dear fellows, for a common name, it's very simple, tertiary butyl, and it is butyl. So butyl, tertiary butyl ether is a common name. I'll add here butyl and tertiary butyl ether. Now, for the IUPAC nomenclature, we have to connect one of the alkyl group with the oxygen. So here we have 2 groups, the tertiary butyl group and the N-butyl group. So it will be easier to connect the N-butyl group with the oxygen. So if 1 carbon is methoxy, 2 is ethoxy, 3 is propoxy, what is 4? Butoxy. And that's your longest chain, 1, 2, 3. So number 2 also has a branch. So the name, yep, 2-methyl and 2-butoxy and propane. Now why propane? Because this is 3 carbons chain. We need the longest chain. Students have made mistake here. Some wrote here 2-propoxy butane. I saw butane here. Everybody was writing butane, but it's propane because the long chain to which the branch and the alkoxy is attached is containing 3 carbons. So that's it. It's a pretty straightforward structure. And if you want to make the skeleton, there's a 4 carbons. So 1, 2, 1, 2, 3, and 4. 1, 2, 3, 4. This is 4 carbon. In fact, here I think it's going to be like this, and then O here. So 1, 2, 3 carbon, and then O. So kindly forgive me on this one. 1, 2, 3 carbon, and then oxygen, and then the methyl. Here 1, 2, 3, 4. So 1, 2, 3, 4. So O goes up. This is oxygen. 1, 2, 3, 4, and O. And then O is attached to carbon, of course. There's a carbon, which also has a carbon, but they have 2 other carbons attached to it. That's how you can make skeleton of the 2-methyl and 2-butoxypropane. So this is the nomenclature repeated because I just thought I should repeat. I had seen some mistakes in the paper, so I just thought I should do it. I'll continue with a similar lecture, and I will now tell you the some other question that students had asked me. It was from the 3rd question. It was question number 14. Now question number 3rd, and the part was 14. And the name was like diisopropyl ether. Diisopropyl ether. You know, isopropyl, right? Ether and isopropyl. So most of the students have made this correct. Diisopropyl ether. Fine. Question was, what will be the IUPAC name? So in the IUPAC name, at least one of the alkyl group will be attached to the oxy. So either way, it's same. So yep, it is isopropyl oxy, isopropoxy. So 1, 2, 3. Yep, 2 isopropoxy and propane. Why propane? Because this is 3 carbons chain. The longest chain, it contains 3 carbon. I hope, although many students have done it already and their answers were also correct, but some students, they had this confusion, so I just wanted to make sure that we can redo this, okay? Now we go towards the ether C2H5O C2H5, diethyl ether, ethoxyethane. It is such an important ether that it's called just ether. I told you this in the lecture of yesterday. However, ether is a name of our entire family. But this one is the major member, the major breadwinner for the family is the ethoxyethane or diethyl ether. It's a very much important chemical in the laboratories as well as in the industries, even at home, you know, we need ether. Ether, if you guys don't understand ethers, then maybe when you were getting some paint work at your house and the guy asked you to purchase some thinner. Now, thinner, yes, the thinner is diethyl ether. It is used as a solvent in paints. If you are familiar with woodworks, and when you are polishing wood, you use lacquer or varnish. These are polishing chemicals for wood. Their solvent is diethyl ether, and it's called thinner. It's extremely flammable, and but it has a power to dissolve even very thick stuff. It can even dissolve fats. So diethyl ether is much important chemical, and we will discuss its uses later in the lecture today. But first, I'm gonna teach you how can we prepare it. So preparation of diethyl ether, or I told you, just ether, commercially known as thinner. If you don't know, maybe your parents would know what is a thinner, and thinner is used as a solvent for varnishes. So the first and most common way to prepare diethyl ether is alcohol, from ethyl alcohol, or from ethanol. So if you guys know ethanol, ethyl alcohol, C2H5 OH, or CH3 CH2 OH. This is ethanol or ethyl alcohol. So if you use ethanol, expect diethyl ether. Can you tell me if I take methanol, what do I get? Yeah, dimethyl ether. If I get propanol, I get dipropyl ether. So mostly simple ethers are produced using alcohols. Now, how can we do it? It's a simple process. Ethyl alcohol is basically mixed with, sodium metal is mixed in the ethyl alcohol. Now, sodium metal, if you guys know, is a soft metal and you cannot dissolve it in water. So maybe some sulfuric acid we will need to dissolve both of them in the ethyl alcohol and sodium metal lumps as well. Both are reactive. Sodium metal is reactive and so is ethanol. So they will very quickly spontaneously react and you will find fumes of gas coming out. That gas will be hydrogen because this hydrogen will be removed. So it's called dehydrogenation. Sodium will come over here and replace hydrogen with itself. So you will see CH3, CH2, ONA, and since there are two molecules of ethanol, so H2 gas will escape. The bubbles, the sound of the gas evolving will basically be the hydrogen gas evolving. And the solution that you will be left with in the beaker is this sodium eth oxide. Sodium, I hope it makes sense. And eth oxide because 2 carbon eth oxide. Sodium eth oxide will be prepared from ethanol when you add sodium metal dissolved in sulfuric acid and you pour into a beaker of ethyl alcohol. You will see a lot of gas coming out of it, and that gas will be hydrogen gas obviously, and you will get sodium eth oxide as a product. Now this solution in the beaker, you will have to add here some other chemical in the second step. I'm going to explain it here. CH3 CH2 ONA, sodium eth oxide, and if you add a solution of ethyl bromide. Now, you know, bromo is partially negatively charged here because it has more electronegativity than the carbon chain. Sodium is positive. So what you expect the reaction to proceed with? Sodium is going to join bromine into an ionic compound, NaBr. So let's forget NaBr. Let's think about this, what we have. CH3, CH2, and O. And Na, no Na, because Na is gone. So if Na is gone, then this carbon, basically, the CH2, the primary carbon, will now proceed to bond because it will be partially positively charged and oxygen is negative. So opposites attract. So you will have O bonded to CH2 and CH3, diethyl ether. Most common way of preparing diethyl ether is from ethyl alcohol, sodium metal sulfuric acid, followed by the ethyl bromide. So this is how you prepare the diethyl ether from using alcohol. So this method is most efficient and quick method of producing a lot of quantities of diethyl ether. And since this method was first used by manufacturers, company called Williamson, so this is known as Williamson synthesis. So Williamson's is basically a company that makes chemicals. So preparing ethyl alcohol, diethyl ether from ethyl alcohol is known as Williamson's synthesis, because it was first time used by this company to commercially produce thinner. Thinner is diethyl ether. Here ethanol is taken and we dissolve in it pre-dissolved sodium and sulfuric acid. We put into ethanol. Our beaker has lots of gas coming out, which is hydrogen, and the sodium ethoxide. We have a reactive substance which can easily react with excuse me, ethyl bromide, and we can end up with diethyl ether. Now this is how the first method to prepare is this. Okay, I hope you can get that one. Okay, next one is from alcohol again, but this time not using sodium metal. Okay, we dehydrate alcohol from dehydration, removal of water. Now, dehydration means the removal of water. How can you remove water from ethyl alcohol? You need a dehydrating agent, okay? Dehydrating agent is a substance which can actually remove water, or which attracts water out of the substance. So if you see here, CH3, CH2, OH, this is one alcohol, and then HO, CH2, CH3, this is another alcohol. Two similar molecules but drawn twice. So in presence of sulfuric acid concentrated, in the actual reaction, basically one of the alcohol molecules bonds with sulfuric acid. Okay, and then I will also do it for you here, but first let's do the simple one. In simple case, the OH from one alcohol and the H from the other alcohol, they make H2O. If they make H2O, then we have what? CH3, CH2, O, and then we have CH2 and CH3 plus H2O. Now this is two molecules of ethanol, and this is diethyl ether. Here I will take a moment and tell you that in the examination there's one question called convert this chemical to that, alcohol to diethyl ether. It's a very common convert question in the annual examination. You can do this one or that one, the same thing, right? But I'll tell you the real thing, what actually happens in this case. So kindly, in the step 1, this is CH3, CH2, OH. Sulfuric acid, is an acid. It can donate proton very easily. H2SO4. Let's write it as HSO4H. Now, it donates proton. It kicks out of the hydrogen atom and takes all the electrons from it, which it becomes proton. So when sulfuric acid comes in contact with ethyl alcohol accepts, because it has a lone pair here, oxygen has a lone pair. So when this is deprived of the electron and it's just a proton, it will immediately make a dative bond with here. Now this will make the ring basically unstable, And of course, this will make H2O. So once the H2O is out, then you will have negatively charged sulfate, this one, and positively charged alkyl group. So obviously, if they are in the same beaker, they will bond, and you will get CH3, CH2, and SO4H. This is ethyl alcohol becoming ethyl sulfonic acid. Sulfonic, pH or F, both work. Now, ethyl sulfonic acid has too many oxygen and it's also acidic. It's again acidic. So it will react with another molecule of ethyl alcohol. Let me make it for you. CH3, CH2, OH, and CH3, CH2, SO4H. Now, when these react, ethyl alcohol and ethyl sulfonic acid, basically what happens that sulfuric acid is recovered. Now this H goes to sulfuric acid and it makes H2SO4. So you have a CH3 and then you have CH2O, and then this carbon, which is left after the removal of sulfonic group, will bond to the oxygen. And you have CH2 and CH3. So what you get? Diethyl ether. Right? This is the actual step 1, and then step 2, how dehydration in alcohol takes place. It takes place with the help of sulfuric acid. Okay? And this is the detail of the process I explained to you, right? First, from alcohol using sodium metal, from alcohol using a dehydrating agent such as sulfuric acid. Keep in mind, ethanol will become diethyl ether. If you take isopropyl alcohol, it will become diisopropyl alcohol. So you can convert any alcohol into the corresponding ether by using sodium metal or by using the dehydrating agent. But there's still one more method to prepare diethyl ether, and it is expensive one, so no one's gonna actually use it, especially when we make ether for industrial purpose. Here we use silver oxide, and silver oxide is can somehow yield silver from ethyl chloride, okay, using silver oxide. Now, from ethyl chloride using silver oxide. So, ethyl chloride is CH3, CH2Cl, and Ag2O is the formula for silver oxide. So, as I mentioned, silver is expensive. They both are solid, so they must be heated, and once they heat, what happens? The chlorine has a huge tendency for the silver. So Ag plus and Cl minus, that. Amazing, they have a huge tendency. So Ag2 and Cl, it will make basically 2 AgCl. Let's make 2 here. 2 AgCl will be the product. But what about the O, which can make 2 bonds and 2 molecules of ethyl group? You might have guessed that this oxygen is divalent, so this will make 2 bonds. One with 1 molecule CH3, CH2O, and other molecule CH2, CH3, and 2 AgCl is the byproduct. So ethyl chloride can convert to diethyl ether by fusing it with dry silver oxide. And this is also important for the exam point of view, because sometimes I've seen convert ethyl chloride to diethyl ether. It is there. But what I said expensive, yeah, industrial point of view, silver is expensive than alcohol. Alcohol is rather very, very cheap. So this, the first method, using ethyl alcohol and sodium metal, is not cheap, basically, yes, but it's very fast. It's the fastest. It gives very quick yield. This is cheaper than this one, but it is a slow. Okay, you can see slow process. This is fast, but the product, the raw material is expensive. So these are three methods how you can make diethyl ether. I hope you will share them and also show me, and you will try to be creative there. Next thing we are going to discuss today is the physical properties. Now this is very much important. Diethyl ether is obviously liquid. It's a colorless liquid, right? Colorless liquid, right? Very strong solvent, very strong solvent. You can use it as a nail polish remover, but it is not used as a nail polish remover because for that we have a different solvent, acetone. But it is used to dissolve varnishes, lacquers, waxes, and it's like the number one solvent of the organic chemistry. But it's highly inflammable. Yeah, inflammable. That means it can catch fire. That's why when you go to the shop of paints and ask them for thinners, the guy will say wait, and he will send his boy to the some other place, like maybe a go down. From there he will fetch it because it's super expensive. And I must share with you my experience. I have an Almirah and it has a oil paint on it. So I purchased the thinner he gave me in a polythene bag, and I put it on the Almirah. I saw after a few hours the diethyl ether was in the polythene bag in a thili, and all the color was gone from where it was placed. So its fumes were coming out very strongly, and the fumes were attacking on the oil paint, and I saw the entire paint was gone. So it's a very strong thinner. I have myself used it, but I was wrong there. I should have taken care. It's very flammable. So if any fire or any crack or something happens, that could be game over for me. So it's a highly inflammable physical property, and very low boiling point. Yes, very low boiling point, which means if you will keep it open, it will disappear. Fumes will come out. Fumes will come out. You can smell it everywhere, and it will be gone. Just like a petrol or nail polish remover. Great solvents are always like this. Okay. It is number one, organic solvent, right? Nobody can be compared to diethyl ether when it comes to dissolving stuff, right? So these are some physical properties of diethyl ether, and chemically it's a solvent. So to be a solvent, it must be chemically stable, which means unreactive, right? A solvent, right? A solvent's job is to dissolve the solute, not chemically react with it. So chemically, it's very stable. Unreactive. And why it's unreactive? Because oxygen is bonded to both sides at the alkyl group, so the chemistry is good and there is no need for the reaction. When you treat it with highly acidic compounds, there it can produce as a Lewis base electron pair donor. Let me explain to you here. C2H5O, C2H5. Oxygen has two lone pairs. So let's take one lone pair. Okay. So when it reacts with a highly acidic compounds like hydrogen iodide for the organic chemistry, it will lose the proton and proton will make a dative bond with this oxygen. You know, dative bond, one-sided sharing. So O, and then you make an arrow like this, you know, from donor to acceptor, right? This reaction proves that diethyl ether is a Lewis base. Lewis base. It acts as a Lewis base, electron pair donor. And from this ion, this is ion, it's called Oxonium Ion. If you know Hydronium Ion, like acid in water, when acid donates proton to water, it makes a Hydronium Ion. Just like Hydronium Ion, we have the Oxonium Ion. And this is this is also a base now. You can see this is also a base. Iodine is also a nucleophile. So, and this is unstable species. So the unstable compound, which is C2H5O, C2H5, and then hydrogen, which is basically called as the oxonium ion, there will be a kind of SN reaction, and iodine will react with it, okay, and this will break. The oxonium ion will break. Iodine will take one of the alkyl groups. The bond will break, and you get C2H5OH and C2H5I. I want you to remember this reaction because this is how we convert diethyl ether back to ethanol or ethyl alcohol. Important for your annual examination, right? So when we put the hydrogen iodide, which is solid, and in the thinner diethyl ether, reaction immediately happens, and you get two layers of liquid inside. One is the ethyl iodide, other is the ethyl alcohol. This is a reaction which shows how to convert the diethyl ether back to alcohols, right? Oxonium ion, as I mentioned, oxonium ion is formed in ether, just like hydronium ion in water. You know, HCl react with water, H2O, let's say HOH, water, lone pair, the two lone pair. The acid donates proton to water and proton accepts it. So you get HOH and another H. You can give plus and minus donor acceptor. This is also called H3O plus. Guys, you should know this is called hydronium ion. We have discussed that like plenty of time. Hydronium ion. Just like hydronium ion with 3 hydrogens around oxygen, oxonium ion is 2 alkyl groups like R, OR, and 1H. Here oxygen has a positive charge. Here oxygen has a positive charge. This is how hydronium and oxonium ion are same. So what is oxonium ion? It is a positively charged species in which oxygen is bonded to 2 alkyl groups and 1 hydrogen group. Total 3 groups. So here three groups, 3 atoms. Here 3 atoms. So any species, this is also oxonium ion, any species in which oxygen is bonded to a charge positively and bonded to 3 groups of atoms is known as the oxonium ion. So this is how it is formed in the ethers. It could be a short question like what is oxonium ion, how it is formed. You can give this reaction as a example, right? This is for water oxonium ion, this is for ether oxonium ion. Hope you understand the chemical reactions. Not too many for the ethers because ether is chemically stable. It is number 1 solvent in the organic chemistry Number one solvent. I will say it again because I have experienced its power, right? Uh, it is so powerful solvent that our book says it is solvent for facts. Now, this is interesting. Used as solvent. In the book, it says for facts. Now, I don't think there's any solvent in the world which can dissolve facts. I wish there were, but there isn't. The word is basically fats. Fats, yeah, it can dissolve fats, okay? It can dissolve waxes from trees and petroleum wax, okay? If you your younger brother or somebody has messed his hand with wax all over his hand, you wash with water, it doesn't go out, but you wash with the ethyl ether, it will be gone clean. This is very strong. Gums, yeah, if your hair has any gum, some of your friend, or by mistake you have a chewing gum attached to your hair, what do? Solution, tell me. You only cut the hair. That's the only way, because you don't know that diethyl ether can dissolve gums. So, but don't try it because it may also dissolve your hair. So it can dissolve gums and resins, products from the trees, lacquers and varnishes. Varnishes are natural product used on the to polish wood, lacquer as well. Okay. So it's the best solvent for them. Okay. Remember, if you remember Wurtz's reaction in 7th chapter, right? In Wurtz's reaction, where methyl iodide was converted to ethane, there it acted as a solvent. You must also, so you can use it as solvent in Wurtz's reaction. If you know Grignard reagent, RMgX. Okay, Grignard reagent is formed by different substances, but the solvent there was dry ether. Again, the action of diethyl ether was a solvent. Okay, and it is, yeah. Let me mention here. It is the first anesthetic. Yes, it is the first anesthetic to be used ever by a doctor. Okay, from history we know opium is the first anesthetic, but that was used by a chemist. Physician, at a medical level, if somebody inhales it, it causes anesthesia immediately, right? It can make smokeless gunpowder, right? Nowadays, the bullets have the smokeless gunpowder, and they're again solvent. All right. So it is a solvent to make in textile. Yeah. Most of its application are as a solvent. Now in textile, you guys know the cotton is first put into a solution form. That the solution form passed through some holes and the fibers come out. So what is a solvent that dissolve the cotton and make a collidon, a mixture? It is diethyl ether. So, my dear friends, I hope this is another long lecture, and I'm really enjoying teaching you here. I'm so glad that improvers are also doing their work and showing me. It tells me how much interested they are. And students from everywhere. And if somebody doesn't know, kindly tell them. And the lecture of first year is also for you. If there's a lecture of first year bio, it's also for class 12 and improvers, because you have to prepare yourself. You have examination, and then you will have entrance test. So a lot will be going on right after this lockdown. So good luck with your homeworks, and kindly show me as well. Here is a little announcement. We will not be working on weekend, so Saturday, Sunday, you guys can enjoy with your family and help your mother in the kitchen somehow, or play football with your dad in the lawn or something like that. 2 days you enjoy yourself, and then I will again see you on Monday with another lecture, and it's very much important, aldehyde and ketone, and I'm very much excited to teach you that. Thank you so much. Have a great time. Have a happy weekend. Goodbye.